As another example, consider what happens if we know delta T, delta S, and V naught. What can we determine if we know a delta T, a delta S, and a V naught? I suggest that you pause the playback and think this through. Begin by making up some numbers and a situation to go with this. What is your delta S, your displacement? What's your initial velocity? What's your delta T? And what can you infer from those quantities? Now, if we consider the situation, we know that delta T and delta S are related by the fact that V bar equals delta T over delta S, delta S over delta T. Our displacement divided by our time interval is our average velocity. So we get our average velocity. Now it gets just a little tricky. If we know the average velocity and the initial velocity, we should be able to determine the final. The reason for this is, under the implicit assumption of uniform acceleration, if we know initial and average, then final has to differ from the average by the same that the initial does. So we just take the difference between average and initial and add that to the average, and we're going to get the final. Little picture here that might be a little hard to see, but we got V naught and VF with V bar in the middle. If V bar is in the middle, then this difference is equal to this difference, and we can easily find VF if we know these two. Now, once we found VF, we put that together with V naught to get our change in velocity. We can always, if we know V naught and VF, we can get our average velocity. Of course, we already have that, or our change in velocity. And that's going to be VF minus V naught. Then putting that change in velocity together with our delta T, we get our acceleration. So we see that given delta T, delta S, and V naught, we can get acceleration and we can get final velocity. We could write equations for these, but as you'll see in a while, that's going to be a little bit redundant. But we could go back, we could say that delta V is VF minus V naught, and put that in here. We could come up with an expression for VF, which is going to be V bar plus V bar minus V naught, and so on. But we're not going to bother with that right here. We just want to look at the idea of charting or representing the flow of the calculations.